Hi, this is David Voss, CCIE 11372, and in this video you're going to learn about security threats and risks. Security is a large portion of the CCDA exam, so you'll need to know everything in this video. It is important to be aware of the different types of attacks that can impact your systems on the network. Security threats can be classified into three categories: reconnaissance, gaining unauthorized access, and denial of service. The goal of reconnaissance is to gather as much information as possible about the target network. Gaining unauthorized access obviously refers to the act of actually attacking or exploiting the network or host. And then denial of service. These aim to overwhelm the resources on the network, such as memory, CPU, and bandwidth, and thus impact the target system and affect the devices on the network negatively. Reconnaissance network tools are used to gather information from hosts attached to the network, and they have many capabilities. They can determine the operating system, identify file permissions, trust relationships, and user permissions as well. Here are some of the popular scanning tools that are used. Kismet is an 802.11 wireless sniffer and IDS system, and it can collect traffic from any 802.11 network. It does this by detecting wireless networks even when they are hidden, and then it can collect packets from those networks. NetStumbler is another wireless network scanner, and it can discover and scan networks even if the SSID is not being broadcast. And then arguably the most popular is Nmap, or Network Mapper, and it's designed to scan large networks, or it can actually be used to scan a single host. It's an open source utility, and it's used for network exploration and security audits. Now, there are different types of scanners, such as vulnerability scanners, and they determine the potential exposures that are present in the network. Here are some of the more popular tools used for vulnerability scanning. SAINT, which is Security Administrator's Integrated Network Tool, is a vulnerability assessment application. MBSA, Microsoft Baseline Security Analyzer, is used to scan systems and identify whether patches are missing from Windows products. And Nessus is designed to automate testing and discovery of known vulnerabilities. It's an open source tool that runs on a variety of operating systems. Next, let's discuss unauthorized access. Hackers use several techniques to gain system access. One approach is when unauthorized people use usernames and passwords to escalate the account's privilege levels. Some system user accounts have default administrative username and password pairings that are common knowledge. In some environments, there are passwords that are well known, and I'll give you one example. I was at a large Fortune 500 company, and we did a security audit, and we ran a password scanning tool, and we found over 50% of the passwords were easily cracked within minutes because those passwords were set to the name of the company. Obviously, it would be rather easy to gain access to whatever system you would like if half the company is using the same password, which can be easily guessed. Needless to say, they fixed that problem with better security policies. But unauthorized access isn't just about setting the appropriate password. It can also be obtained through the use of social engineering. Actually, most confidential information, such as badges and usernames and passwords, can be uncovered simply by walking around an organization. In addition to social engineering, hackers can obtain account information by using password cracking utilities or capturing network traffic. These automated software tools are very powerful, and as long as you have network access in any way, they can easily be run, and you can easily obtain the information you need if security is not properly implemented. Next, let's talk about security risks. To protect network resources, processes, and procedures, technology needs to address several security risks. Important network characteristics that can be at risk from security threats include data confidentiality, data integrity, and system availability. Let's talk about that now. Data confidentiality should ensure that only legitimate users can view sensitive information. Data integrity should ensure that only authorized users can change critical information. And system availability should ensure uninterrupted access to critical network and computing resources. In addition, the use of redundant hardware and encryption can significantly reduce the risks associated with all these three: system availability, data integrity, and data confidentiality. Next, let's discuss targets. Given the wide range of threats, just about anything on the network is vulnerable and is a potential target. Individual hosts are usually the number one thing that hackers are looking to access, but they're especially susceptible to worms and viruses. Other high-value targets include devices that support the network. So obviously, this would be routers and switches, possibly even firewalls. DHCP servers and DNS servers certainly, and management stations such as SNMP or even IP phones. Next, let's talk about loss of availability or denial of service. DOS attacks try to block or deny access to impact the availability of network services. Here are some common failure points due to DDoS attacks. A network device, a host, or an application fails to process large amounts of data sent to it that then crashes or breaks communication ability for that device. A host or application is unable to handle an unexpected condition that was sent to it, and therefore there's resource depletion or failure. And nearly all DOS attacks are carried out with spoofing or flooding methods. Now, that being said, Cisco provides you many tools to deal with this, and here they are for you now. DHCP snooping, dynamic ARP inspection, unicast reverse path forwarding, access control lists, and rate limiting. If you study this chart and know it well, you will most certainly be prepared for the CCDA exam when it comes to how to manage against denial of service attacks. When attackers change sensitive data without authorization, it's called an integrity violation. So, for example, an attacker might access financial data, change it, or delete it. It's important to use restrictive access controls to prevent integrity violations and confidentiality attacks. And here are some ways you can enforce access control and reduce risks. You can separate networks using VLANs and packet filtering firewalls, restrict access with operating system-based controls, limit user access by using user profiles, and then use encryption techniques to store your data. The security policies an organization employs use what are called risk assessments and cost-benefit analysis to reduce security risks. The following figure shows the three components of risk assessment. Control refers to how you use the security policy to minimize potential risks. Severity describes the level of the risk to the organization. And probability is the likeness that an attack against the assets will occur. A risk assessment should explain what assets to secure, the value of those assets, the loss that would result from an attack, the severity and probability of an attack against the assets, and how to use a security policy to minimize the risks of the attack. In many cases, security costs can be justified by describing the loss of productivity or revenue that could occur during security incidents. A risk index is used to consider the risks of potential threats. The risk index is based on the risk assessment components, which are severity of loss if the asset is compromised, probability of the risk actually occurring, and ability to control and manage the risk. One approach to determining a risk index is to give each risk factor a value from 1 to 3, 1 being the lowest risk and 3 being the highest. So, for example, a high severity risk would have a substantial impact on the users or the organization. Medium severity risks would have an effect on a single department, and low severity risks would have limited impact. The risk index is calculated by multiplying the severity times the probability factor and then dividing by the control factor. The following is an example of a risk index calculation for a typical large corporation. So here's what you've learned. You've received a really good introduction to security, and I know there's a lot in this video actually, but yes, it is just an introduction still. You've learned about network attacks, reconnaissance scanners, vulnerability software, security risks and targets, denial of service, preventing breaches, and performing risk assessments. All of these were basic introductions, but at the level you will need for your CCDA exam. There again is plenty to learn after this, but this lays a solid foundation for you moving forward in your studies. Good luck. Hi, this is David Voss, CCIE 11372, and in this video we're covering security policy and process. In this video you're going to learn about network security elements, and then we're going to dig a deep dive into security policies, including their purpose, the development of security policies, and the security policy lifecycle. So let's begin. To provide the proper levels of security and increase network availability, a security policy, is a crucial element in providing secure network services. It's an important concept to understand, not just for the CCDA exam, but to function in today's environments where security is so crucial. Business requirements and risk analysis are used in the development of security policy, and it is often a balance between ease of access versus the security risk and cost of implementing the security technology when making decisions. In terms of network security in the system life cycle, the business needs are a key area to consider. These needs define what the business wants to do with the network. Risk analysis is another part of the system life cycle which explains the risks and their costs. So business needs and risk assessment feed information to formulate the security policy. The security policy describes the organization's processes, procedures, guidelines, and standards. Finally, an organization's security team needs to have the processes and procedures defined. This information helps explain what needs to happen for incident response, security monitoring, maintenance, and compliance. As you can see here, the consideration is prefaced with a question, and then you can see what aspect of security preparation and policies and procedures can deal with that consideration. It's key that you memorize this chart for the CCDA exam. RFC 2196 says, a security policy is a formal statement of the rules by which people who are given access to an organization's technology and information assets must abide. So when you are developing security policies for an organization, RFC 2196 can serve as a guide for developing security processes and procedures. The basic approach of creating a security policy is to identify what you are trying to protect, determine what you're trying to protect it from, determine how likely the threats are, implement measures that protect your assets in a cost-effective manner, and then review the process continuously and make improvements each time a weakness is found. One of the main purposes of a security policy is to describe the roles and requirements for securing technology and information assets. The policy defines the ways in which these requirements will be met. There are two main reasons for having a security policy. First, it provides the framework for the security implementation, and then it creates a security baseline of the current security posture. Here are some questions you might ask when developing a security policy. What data and assets will be included in the policy? What network communication is permitted between hosts? How will policies be implemented? And how will the latest attacks impact your network and security systems? A security policy is divided into smaller parts that help describe the overall risk management policy, identification of assets, and where security should be applied. There are other documents which concentrate on specific areas of risk management. The acceptable use policy. This document defines the roles and responsibilities within risk management. Network access control policy defines access control principles used in the network and how data is classified. Security management policy explains how to manage the security infrastructure. And then incident handling policy defines the processes and procedures for managing security incidents. If you look at this chart and memorize it, you'll do excellent on this portion of your CCDA exam. As requirements change and new technology is developed, the network security policy needs to be updated to reflect those changes. So here are some steps that are used to facilitate the continuing efforts in the maintenance of security policies. Secure, monitor, test, and improve. Secure means identification, authentication, ACLs, VPNs. Monitor, intrusion, and content-based detection and response. Test is assessment, vulnerability scanning, and security auditing. And improve is for data analysis, reporting, and intelligent network security. Today's network designs demonstrate an increased use of security mechanisms and have become more tightly integrated with network design. Trust and identity management is a part of the SAFE security reference architecture and is crucial for the development of a secure network design. This management of trust and identity defines who and what can access the network, when, where, and how that access can occur. If you take a look at the following diagram, it shows the main three components of trust and identity management are trust, identity, and access control. So let's talk about each of these three. Trust is the relationship between two or more network entities that are permitted to communicate. Domains of trust are a way to group network systems that share a common policy or function. Network segments have different trust values depending on the resources they are securing. Therefore, domains of trust can be applied. These types of security controls can be applied to network segments, as it is important to consider the trust relationships between segments. Here's an example of domains of trust. You have your internet access edge, and then your DMZ, and then your internal network. Each of those are separate domains. Obviously, on the internal network, you just want the appropriate internal users. In the DMZ, you're allowing a blending of the two. And on the internet, obviously, you just are expecting for there only to be exterior users on that portion of the network. So how you apply security will greatly depend on the domain of trust you are trying to protect. Identity is the who of a trust relationship. These can be users, devices, or organizations, or a combination of all of the above. Network entities are validated by credentials, and authentication of the identity is based on the following attributes. Something the subject knows, such as a password, something the subject has, such as a possession, and something the subject is, such as a human characteristic, fingerprint, retina scan, etc. The first two are the most likely and the most popular ways of securing something you know and something you have with you. Most companies are now expecting two-factor authentication. So here's what you've learned. You've learned about network security elements, and then we dug into the security policies in detail, at least enough for you to know for your CCDA exam, digging into the purpose, development, and life cycle of security policies. If you know what's in this video, I'm confident you'll do well in this portion of the CCDA. Good luck in your studies. Hi, this is David Voss, CCIE 11372, and in this video you're going to learn about Cisco SAFE. Specifically, we're going to do an overview of Cisco SAFE, and then we will talk about securing the individual modules of the enterprise campus. So let's begin. The Cisco SAFE, or Security Architecture for the Enterprise, blueprint provides to network and security designers guidelines for implementing security mechanisms for the Cisco campus design. The SAFE blueprint follows the enterprise composite network modular approach presented throughout this entire video series. All of the SAFE strategies are applied to each module and component of the enterprise architecture model's design. From a network design standpoint, the SAFE blueprint is a security architecture that covers the following aspects: attack mitigation policy, enterprise-wide deployment, secure reporting and management, authentication and authorization, IDS, and ongoing support for emerging technology. The policy for attack mitigation ensures that possible attacks and threats to the organization can be identified and defines the countermeasures that will be used against those attacks. The SAFE blueprint is usually applied in an enterprise-wide deployment, not just to an isolated component. It also provides methods and mechanisms for ensuring that the reporting, management, and auditing are accomplished in a secure fashion. It includes secure authentication and authorization with strong encryption and digital signing techniques, including public key infrastructure, PKI. It also includes intrusion detection services for critical resources and networks. The SAFE blueprint provides ongoing support from Cisco for all the emerging technologies it provides. The SAFE blueprint allows you to apply a systematic approach to security from a modular standpoint. Risk at the Internet connectivity block would include the following: reconnaissance tools, port scanning tools, IP mapping tools, mail relay, distributed denial of service, and malware, including malicious code, viruses, Trojan horses, and worms. In order to secure the Internet connectivity block, the SAFE blueprint recommends the use of firewalls, router access lists, and network IDS to mitigate the risks presented already. You should also consider hardening the network devices and servers in that particular block. You can also build DMZ networks to isolate specific devices from the network infrastructure. For many organizations, the e-commerce block may get its Internet connectivity through the Internet connectivity block, or it may have its own connections to an ISP. Regardless of this aspect, the risks and guidelines for the e-commerce block are very similar to the Internet connectivity block recommendations. According to the SAFE blueprint, in this block you should protect high-profile e-commerce servers, as this is where you will also encounter the defacing of web services technique. The e-commerce block is also vulnerable to denial of service and distributed denial of service attacks. Countermeasures in the e-commerce block involve using access lists, filtering, and firewalls that protect the database, applications, or transaction servers. The server should be hardened by using only the necessary applications and ports. Ensure that the e-commerce applications are secure by frequently updating and patching them. Cisco IDS should also be used, and the e-commerce block should be placed into a dedicated DMZ zone to isolate it from other blocks of the network. The VPN and remote access block is often connected through the internet connectivity block to various internet service providers, so you should use common techniques for securing it. However, because you will be using VPN technologies, some unique security mechanisms can be implemented. Because remote access and VPN networks often use the public internet or PSTN as their carrier, you should be aware of possible spoofing techniques that will allow an attacker to impersonate a legitimate client and get remote access or VPN access to the enterprise network. The network becomes vulnerable to spoofing if the attacker is able to steal credentials or guess the authentication key. In order to secure the remote access block, you should carefully implement VPN technologies using dedicated equipment, which includes advanced security mechanisms. You can use the IPsec protocol to assure proper authentication, authorization, and encryption, and IDS and firewall equipment can be used as well. In order to secure the WAN block, according to the SAFE blueprint, VPN techniques are used to ensure point-to-point secure connections. You should also use strong cryptography methods such as triple DES or AES to provide the confidentiality and integrity of the data packets. In addition, use authentication with all the WAN peers and harden the WAN routers to ensure that only the necessary protocols and ports are used. Additional security measures including using filtering techniques based on Cisco access lists and on network devices. The network management submodule must be secured, and it's especially vulnerable to inside attacks. The written security policy should describe the procedures that apply to this submodule, and a best practice is using AAA services. These are usually based on Radius or TACX servers that will provide authentication. Other possible problems might involve administrator impersonation for individuals who might want to get administrative level privileges that will provide them access to all the other blocks in the Enterprise Campus module. In order to mitigate these threats, you should use strong encryption techniques and SSH instead of Telnet for remote administration. In the server farm block, the main goal is to protect the servers using strong and secure operating systems and applications. The servers should be periodically verified to ensure that they have all the proper updates and patches and that they are hardened. The server farm block can include firewall policies that will assure proper access control, as well as switch ACLs that will only allow certain traffic to flow at the data link layer. IDS should also be used in this block to ensure connectivity to other campus blocks. The access layer block is the place where the end hosts and the lower end access switches are located. In order to secure them, you should use HIDS technologies, in addition to the standard hardening techniques, which will only allow the necessary application, services, and ports to run. If the access layer block also includes complex IP telephony integration, special measures must be taken to secure the VoIP infrastructure. So here's what you've learned. You've received an overview of Cisco SAFE, and then you've learned about securing the individual modules of the enterprise campus. All of this information you will definitely need to know for your CCDA exam. Good luck in your studies. Hi, this is David Voss, CCIE 11372. And in this video, you're going to learn about security management. Specifically, you're going to learn about security threats and risks, security targets, security policies, and then threat defense. So let's begin. The CCDA candidate must understand the reasons for network security, including the systematic approaches to managing security. Cisco invented a concept called self-defending network, which describes the network infrastructure and the services used in order for the network to respond to attacks. First, let's talk about security threats and risks. Efficient security mechanisms must address organizational threats and mitigate risks successfully. The network designer should create a secure environment for the organization by doing everything he can to prevent attacks, while ensuring that the security features have minimal effect on end-user productivity. A network security implementation must mitigate multiple factors and accomplish the following: block outside malicious users from getting access to the network, allow only system, hardware, and application access to authorized users, prevent attacks from being sourced internally, support different levels of user access using an access control policy, and safeguard the data from being changed, modified, or stolen. The next thing we will concern ourselves with are the targets. What are the targets on the network? And this helps you develop a good security policy and posture. Targets on the network include the following: any kind of network infrastructure device such as a switch, router, security appliance, or wireless access point; network services such as DNS, ICMP, DHCP; endpoint devices, especially management stations that perform in-band or out-of-band management; and network bandwidth, which can be overwhelmed by denial of service attacks. The security policy is a small part of a larger network security system lifecycle that is driven by an assessment of the business needs and comprehensive risk analysis. Risk assessment may also need to be performed using penetration testing and vulnerability scanning tools. The security policy should contain written documents that include the following: guidelines, processes, standards, acceptable use policies, architectures and infrastructure elements used, and then granular areas of security policy such as internet use policy or access control policy. The most important aspects covered by the written security policy and procedures are identifying the company's assets, determining how the organization's assets are used, defining communication roles and responsibilities, describing existing tools and processes, defining the security incident handling process, and then a steering committee will review and eventually publish this security policy after all the important documents have been finalized. Some of the best practices for protecting the network infrastructure through trust and identity include the following: use AAA services with the Cisco ACS server, use 802.1x, port authentication, logging using syslog and SDEE. This is a protocol used by Cisco IDS and IPS sensors to send information to the management stations. Using SSH instead of Telnet to avoid any management traffic crossing the network in clear text. Using secure versions of management protocols such as SNMP version 3, NTP version 3, and SFTP. Harden all network devices by making sure unnecessary services are disabled. Use authentication between devices that are running dynamic routing protocols. Use the Cisco one-step lockdown feature on network devices to harden them. Use ACLs to restrict management access, allowing only certain hosts to access the network devices. Use IPsec as an internal encryption method or external VPN solution. And then use Cisco Network Admission Control Solution, which ensures that network clients and servers are patched and updated in an automated and centralized fashion. So here's what you've learned. You've learned about security threats and risks, security targets, security policies, and threat defense. All of these you will need to understand, not only for your CCDA exam, but also to support your own network. Good luck in your studies.